Alright, we are looking at logarithms now. And I'm just going to go over the highlights of logarithms. If you've never had them before, this will not be enough. If you've had them before and need refreshed, hopefully this will be enough. The whole point of logarithms is to solve an equation in which the variable is an exponent, or the exponent is a variable. So simply what this means, so this, first of all, this is read log base 3 of 9 equals 2. And here's all it means. It means 3 to the second power equals 9. That's all it means. Now, as simple as that is, 3 to the second power equals 9. The problems in which you use this are not so simple. Let's look at some of the properties. First property, log base b of b equals 1. Well, that makes sense, because if you change this to be in this form, it's going to be this base b to the first power equals b. Of course, b to the first equals b. The second one, if you change this to exponential form, it's going to be b to the 0 equals 1. Of course, that's true. Anything to the 0 power is 1. Number 3, if x equals b to the y, then log base b of x equals y. Of course, that's true. Let's look at this in the backwards direction. What this is saying is b to the y equals x, which is what this says over here. Number 4, this is not as intuitive, but if you understand the exponent rules, then maybe it is as intuitive. If you are multiplying, this is called the argument here. The argument is what comes after the base. You could rewrite the problem so that it's log of the base of the first number that you're multiplying, in this case x, plus log of the same base of the second number you're multiplying, which would be y. Just a quick example, if you had log base 7 of 2x, you could rewrite that, if you chose to, as log base 7 of 2 plus log base 7 of x. The next one, number 5, says that if you're dividing your argument, then you can subtract two separate logarithms with the same base. So an example, say that we had log base 2 of 8 over 2. That's the same as saying log base 2 of 8 minus log base 2 of 2. The next one is the power property. This one's super powerful. If your argument has an exponent, you can write the exponent as a coefficient. So example, say we had log base 10 of 5 to the second. We can take the exponent of 2 and write it as a coefficient. Super cool. Number 7 means that no matter what calculator you have, you can more than likely use your calculator to do many of these problems. Change of base formula. If you have a base that you don't like, for example, if you have an older calculator, the only bases you can use are 10 and e, you can take the argument and write that as the argument of the numerator. You can take the base, write that as the argument of the denominator, and then you can choose the new base to be anything that you want as long as it's the same on top and bottom. In most cases, you're going to choose that base to be a 10 because it makes it super easy to use your calculator. All right, let's look at this example. What is the value of log base 9 of 27? Well, first of all, you can use your calculator, the change of base property. You could do log base 10 of 27 divided by log base 10 of 9. Put that in your calculator, and you are going to get 3/2 as the answer. Let me show you how you can do this using algebra, and it's not as simple if you don't know anything about logarithms. If you do, then it's probably faster. So what I'm going to do is I'm going to take this and set it equal to just a random variable. Then I'm going to change it to exponential form. That would be 9 to what exponent equals 27. Now 9 to the second power, well 9 to the first power is 9. 9 to the second power is 81. So that tells you that the answer has to be between 1 and 2. Therefore, this can't be the answer, this can't be the answer, this can't be the answer. So you're down to multiple choice of either B or C. Now if you can make the left and right side of the equation have the same base, then the answer is going to be kind of obvious. So 27 and 9 we could both write as a base of 3. 9 would be 3 squared. 27 would be 3 to the third. Power of a power property, 3 to the second to the x is 3 to the 2x. Since our bases are both the same, we can set the exponents equal to each other. Therefore, x is 3 over 2. Much faster to use your calculator for that. Now the homework gets a lot deeper with logarithms, and really, if you've never had them, in most cases those harder problems you're just going to guess on the ACT, because it would take hours for me to explain that in a video. Alright, good luck.